I'm just doing this so we have one that's dissected out in pieces already. And you're supposed to remove the hindbrain first, so. Okay, removed. All right, so there's our two brains, our brain cut in half. The texture of a human brain is like Jell-O, and it's soft Jell-O. So think of Jell-O at room temperature, and you know how if you were to take it out of a mold, how it would just kind of go bleh, and you know how it would, if you tried to cut it, it would kind of ooze, and that's what real brains are like. Now, the one thing that helps keep them be less like that is the fact that they have blood pressure in them. So the blood pressure kind of stiffens up the tissue. As you preserve them, what it does is it actually stiffens the tissue. So that's one of the things that's really, I mean, this is still pretty soft, but it's even softer than this. So the tissue doesn't really hold up well. Okay, so when they cut these, you want them to make sure that they cut them really straight. I didn't do a good job of that. Because of that, we've got some extra slices on that one side especially. Okay, so let's turn to our brain handouts next. So again, what I did was I gave you a whole bunch of background information behind here about brain functions and parts. And then the actual dissection sheets for these, I gave you a set of handouts with those as well. It used to be that, of course, this was just considered basically trash material and they didn't really do much with it. But as we've had some diseases that affect the central nervous system take place in animals and they've been transferred to humans, there's a lot more care with making sure that these organs are not damaged during the time that animals go through the slaughterhouses. But when you see like these, the really cool thing about these brains is you can actually see the blood vessels on the outside. And your body's the same way. You have a network of blood vessels on the outside. This brain, where you've got this darker tissue on top of it, that's just a network of fine blood vessels. If the brains had been damaged severely, you would actually see like big blobs of blood or something on here, okay? So it's kind of a little bit different. Okay, so let's do an external examination of your brain. So take a look at your brain on the outside, okay? You can see the spinal cord at one end, which we already looked at, and I cut off the end of mine, and if you look really super closely, you can see the horns. You can actually see the structure that looks sort of like a butterfly inside of that spinal column. So spinal column is that stalk that's hanging off the end.
Where did you cut to be able to see that?
Just cut a few inches up from where they've made their, or I should say, probably less than 5 centimeters up from where they've cut, just so that you have a clean cut on the brain. Some of you might have some issues with your brains maybe damaged by the processing. So,
Move the bag down.
Okay. So when you look at this, you can kind of see light and dark in there, and you may actually even see a little tiny tube in there, and that's a tube that actually bathes the inside of that spinal column with fluid. Okay, and then you flip the brain over, and if you go to the very front of the brain, you see these funky little things sticking out on top. Those are olfactory. That's actually where your sense of smell is located, and your brain is the same way. So your olfactory is at the very front, and on these brains you can see they just kind of flop out there, look like two little ears that can be held up in the middle. Okay, and remember we looked at the eyes, and right back here, remember I talked about the neurons, the nerves from this would be the sheep's right eye, come back here past these olfactories, and then they cross, and this is the point where they cross, and you can actually see in my brain, or my sheep's brain, where the two neurons come together in a bundle in the middle and then cross over. And so the same thing would be from the left side comes back here, comes into this optic chasm and then cuts back off to the other side. And again, like we said, it's going to go all the way back here to the back part of the brain. So that's going to be where the person or where the organism's visual cortex is at, is on the very back. Then you have an area called the midbrain. And then this area in here is called the pons. And back here is the medulla.